While we have gravity weighing us down on Earth, the lack of it in space makes for some very strange experiments. And be it playing around with earthly life forms or testing the limit of physics, astronauts have conducted some pretty incredible tests in zero gravity. So join me for today's video. We're going to count down the top 15 most awesome space experiments. Number 15. Space fires. While burning things in space may sound like an awful idea, Flame Extinguishment 2 was a test that tried to see what would happen when fuel was lit on fire. Rather than combust, the lack of gravity causes the fire to expand into a beautiful sphere. It's these types of experiments that not only help scientists make spacecraft safer, but also help determine what fuels are the most efficient for both on Earth and in the vacuum of space. Number 14. Space crying. While Canadian astronaut Chris Hadfield may have had an on-screen that rivals some professional actors, one thing he cannot do is cry on demand. However, in his stint as the commander of the International Space Station, or ISS, between late 2012 and early 2013, he conducted an experiment where he simulated crying in space. To do so, he took his water sprayer and placed some water on his eye. However, rather than fall down his face, the water simply turned into a big ball and stayed in place until he dried it with a towel. Number 13. The satellite spacesuit. Without any context, this video of what looks like an astronaut being shoved into outer space is absolutely terrifying. Thankfully, the reality is far less grim. Nicknamed Mr. Smith, it's actually a Russian Orlan spacesuit stuffed with a bunch of old clothes and a radio transmitter. The hope was that the old suit could be repurposed as a satellite. However, after being thrown out into the void on February 3rd of 2006, its mission was only partially successful. While it did manage to send out signals for about 2 weeks, they were extremely weak, making this suit unviable for a sustained satellite program. Number 12. Fidget spinning. Unless you lived under a rock in the mid-2010s, then chances are you've heard of fidget spinners. Constantly spun by kids between the ages of 5 and 15 for the better part of a year, they died out almost as quickly as they became relevant. However, they were relevant just long enough for NASA to try them out in space. In the video, we see that when a fidget spinner is spun, it will float around and continue to spin on its axis. However, while the lack of air pressure allows for longer spins, the reality is that their spin times are very similar to their earthly counterparts. However, if an astronaut managed to get the entire spinner twirling around, that is, not just on its axis, but the whole device, then it could hypothetically spin forever. Number 11. The space tether. While the idea of tethering a massively electrically charged machine to a spaceship may sound a little crazy, that's exactly what was attempted by the space shuttle back in the 1990s. That's because between the two missions in 1992 and 1996, an attempt was made to deploy a satellite that was attached to the shuttle via a 21-kilometer-long conducting tether. A joint effort between NASA and the Italian Space Agency, the hope was that it could generate an electric current as it cruised through the Earth's magnetic field. However, the first time around, the reel jammed after unspooling just 256 meters, and the second time, 19.7 kilometers of cable were released before the tether snapped, shooting the satellite away into a higher orbit. However, while the two experiments were a failure, the satellite did manage to generate 3,500 volts and up to half an amp of current while in operation. This meant that the concept did have some potential. However, given that the space shuttle is no longer in service, the chance of anything being done with the concept in the near future is slim to none. Number 10. Mouse babies. Having babies in space is a difficult endeavor. After all, beyond the whole making them part, it's a very real risk that microgravity could disrupt the pregnancy. And that's not to mention the fact that radiation in space is more than 100 times stronger than that on Earth. Now, while this may make mouse babies seem like an absolute no-go, the reality is not so clear. You see, in 2017, mouse sperm was freeze-dried, flown around on the International Space Station for a few months, and then used to make babies. Now, while the test on the space sperm did find slightly increased DNA damage, it seems like the fertilization process fixed all of that damage. Better yet, birth rates and male-to-female ratios were normal, and the space pups went on to have healthy pups of their own. Now, is this proof that we can start having babies in space? Probably not. After all, mice and men are very different, and there's a fair chance that human DNA may be damaged far more than that of mice while in space. However, what the experiment does show is that the effects of radiation may not be as bad as scientists initially thought. Number 9. Adidas Moon Boots. For years, all footwear research has occurred right here on Earth. However, as brands such as Nike and Adidas try to best each other, the competition has become fierce, and in a bid to separate themselves from the rest, Adidas is planning on doing some pretty insane space research. The basic premise is that Adidas is going to test 2 different plastic pellets made of 2 different polymers. Each will have slightly different molecular structures, and the hope is that these experiments done in space will make the shoes significantly more comfortable for athletes here on Earth. Now, I should be clear that while there will hopefully be some serious research, the whole thing also smells of a publicity stunt. After all, the company launched a line of $180 space race sneakers when it announced a partnership with the ISS National Lab 1 year earlier, which is in line with similar gimmicky stunts such as when Budweiser sent barley seeds up to the ISS in 2015, or when Nickelodeon sent up a glob of green slime in 2020. However, the simple fact that these companies are interacting with space, it will hopefully lead to some form of useful scientific research while also helping to promote interest in space to the general public. Number 8. Space lettuce. For decades, astronauts have had to eat freeze-dried foods that were far from fresh. However, in the last few years, fresh produce has been a staple on the ISS. Although this produce also comes with a twist. You see, while several vegetables have been grown in space, space lettuce has been the most successful. The first space lettuce experiment happened in May of 2014, which was shortly after NASA's first-ever vegetable production system was delivered to the space station. Once the lettuce was grown, it was sent back to the Kennedy Space Center, and once proven to be safe, a growing program began. Now, it should be noted that not just any regular lettuce was chosen, but a strain known as outrageous. As the name suggests, the lettuce is red, and it was chosen because it germinates reliably, grows rapidly, and tolerates unique lighting conditions on board the ISS. And it does show levels of native microbes on the leaves. In what was quite the twist, the lettuce also appeared to have more or less the same nutrient makeup as lettuce on Earth, despite the stressful growing environment, making outrageous lettuce an excellent choice for space produce. What's great about this lettuce is that it also solves a problem often faced by astronauts. You see, astronauts can lose about 1% of their bone mass for every month spent in space. However, lettuce can be grown with the human parathyroid hormone, or the PTH peptide, which helps stimulate bone growth. The variety of vegetables that can be grown in space is also quite large, as Chinese cabbage, radishes, and Russian kale have all been successfully germinated. So, I think you'd agree, the space lettuce experiment has been a resounding success. Moving on to number 7. Space spiders. Spiderwebs are pretty strange creations. After all, experiments on Earth have shown that when spiders ingest various drugs, the way they build their webs completely changes. This has led scientists to ask an intriguing question. If drugs could change the way spiders spin webs, would the vacuum of space do the same thing? To test out the theory, NASA sent 2 golden silk orb weaver spiders named Esmeralda and Gladys on a 45-day journey aboard the ISS. In order to make sure that they were comfortable and as relaxed as possible, the scientists made the whole thing a lot like a spider vacation. After all, the habitat not only had light conditions to simulate a day-night cycle, but also featured top-tier temperature and humidity control, and of course, a healthy diet of juicy fruit flies. The results were astounding. Despite being in the rather treacherous vacuum of space, the 2 spiders adapted wonderfully to their new home, as they continued to spin webs and hunt for food as they normally would at home. It's also worth noting that their species of spider eats their web at the end of each day to regain protein, and then respins it again in the morning. What was surprising to the astronomers was that even though they weren't on Earth, they did this right on schedule, suggesting that being in space had little impact on their activities. Now, I should be clear that not everything was normal. After all, likely thanks to the lack of gravity, the spiders' webs were flatter and rounder than the more three-dimensional asymmetrical webs that are spun on Earth. However, all in all, the experiment was not only a success, but even had further positive effects, as it was streamed live for hundreds of thousands of kids to see and be inspired from. Number 6. Space microbes. If COVID-19 taught us anything, that's that viruses can be quite dangerous. However, in the vacuum of space, it turns out that the infectiousness of these viruses can be far, far worse. You see, in both 2006 and 2008, 2 missions were conducted that tested the virality of Salmonella bacteria in space. What they found was pretty crazy. It turns out that Salmonella bacteria is 3 to 7 times more virulent in space than on Earth. This means that aboard structures like the ISS, even one small virus on board can rip its way across the crew, quickly making everyone sick. But this leaves one important question. Really, at the end of the day, why does this matter? Well, take the Apollo 7 mission as an example. During this mission, Commander Walter Schirra Jr. came down with a head cold, and before long, all 3 mission astronauts were sick. This was a problem because despite it being a minor illness, the lack of gravity caused all the mucus to collect in their heads rather than stay in their nose. This made them extremely uncomfortable, so much so that they even refused to wear their helmets when re-entering Earth. And while they did manage to pull this off safely, ever since, a 2-week quarantine has become mandatory for all NASA astronauts. To make matters worse, being in space can even reactivate viruses that used to be dormant in your body. For example, it's been found that the herpes virus and the virus that causes chickenpox can reactivate in space, and that while it sometimes causes symptoms, sometimes it can't have any despite still being contagious. So, while current experiments have already been scary enough, even more will have to be conducted in order to find out the true destructive potential of viruses in space. Number 5. The Hammer and the Feather. Sometime between 1589 and 1592, the famous Italian scientist Galileo Galilei climbed to the top of the leaning tower of Pisa for an experiment. He brought 2 different spheres with him. While each had the same volume, they had a different mass. His hypothesis was simple. Even though one sphere was heavier than the other, because they were dropped at the same time, they would reach the bottom of the tower at the same time. Galileo was correct, countering the classical belief of Aristotle that a heavier object would fall faster than a light one. In theory, this same logic should extend to things at the extreme end of the spectrum, such as hammers and feathers. Now, on Earth, external factors such as a gust of wind could skew the results in favor of the hammer. However, in the vacuum of space, Galileo's experiment should hold true. In order to test the theory, Commander David Scott of Apollo 15 decided to conduct an experiment on the Moon. On August 2nd of 1971, Scott took a 1.3 kilogram geological hammer in one hand and a .003 kilogram falcon feather in the other, and dropped them at a height of about 1.6 meters off the ground. As expected, they both fell in sync. In a report written by NASA astronaut Joe Allen, he stated that, quote, "Within the accuracy of the simultaneous release, the objects were observed to undergo the same acceleration and strike the lunar surface simultaneously, which was a result predicted by well-established theory, but a result nonetheless reassuring considering both the number of viewers that witnessed the experiment and the fact that the homeward journey was based critically on the validity of the particular theory being tested," end quote. In any case, the feather and the hammer are still up on the Moon today, standing as a testament to scientific experimentation and curiosity. Number 4. Ultracold Experiments. On Earth, it can get cold, really cold. After all, if you fly out to the East Antarctic Plateau, temperatures can dip down to an incredibly frigid -92 degrees Celsius. However, in space, things can get even more extreme. That's because on the ISS, there's currently a testing facility that can recreate temperatures that are the absolute coldest that matter can possibly reach. You see, as far as we know, the absolute coldest temperature is absolute zero. In other words, 0 Kelvin, or about -273 degrees Celsius. The basic premise here is that all particles vibrate, and the more that they vibrate, the warmer that they are. Therefore, because particles completely stop moving when at 0 Kelvin, it's physically impossible for anything to be colder than that temperature. This is where the ISS comes into play. You see, in 2018, NASA launched the Cold Atom Lab, or CAL, up to the ISS. CAL is incredible because it can produce temperatures that are just a fraction of a degree above 0 Kelvin, making it the absolute coldest facility in the universe. Now, this leaves one question. Why does this matter? Well, ultra-cold atoms can be more than 200,000 times slower than room temperature atoms. This is important because at this temperature they lose their individual identities, fusing to form a bizarre state of matter called a Bose-Einstein condensate. These condensates are crucial because it's believed that they can be used to do everything from the practical, such as improving satellite navigation, to the abstract, such as testing the fundamental theories of physics and modeling the early universe. Best of all, since the ISS is a microgravity environment, the types of tests that can be conducted here are far more varied and arguably more useful than those that would be conducted on the Earth. Therefore, as the technology behind CAL continues to improve, there's a very good chance that the experiments it conducts will reach new heights. Number 3. Moon trees. The vacuum of space, it isn't known for being filled with plant life, and as a result, for a while, many experts believe that the microgravity could have a negative effect on plant growth. More specifically, there was an idea that if seeds were brought up to space, there was a chance that they would turn into duds that were unable to germinate when planted in the ground. Therefore, it was decided that this theory had to be put to the test, and in order to do so, NASA recruited a certain Stuart Rosa to conduct an experiment. As a former forest fighter, he was seen as perfect for the job and was blasted up on Apollo 14 with a metal canister filled with about 500 seeds. The seeds were selected from the loblolly pine, California redwood, American sycamore, Douglas fir, and American sweet gum, and once in space, they were in Rosa's care as he orbited around the moon. While they didn't make it onto the moon's surface, they did experience the effects of weightlessness, while at the same time, control seeds were left on Earth to measure the differences in results. Once the mission was over, the seeds were brought back to Earth, allowing what should have been a generation of moon trees to take root. However, there was one problem. NASA screwed up the experiment. You see, once they reached Earth, the seeds were decontaminated as per NASA protocol. This meant that the sealed bags had to go through a vacuum chamber, and when they did, the bags accidentally burst, scattering the seeds. While a geneticist at the Forest Service sorted them by hand and passed them on to NASA scientists, they received only a minor amount of attention. While some experiments were done using the seeds, most were sent to municipalities and research facilities to do as they pleased without any NASA supervision. However, Dave Williams, who was a planetary scientist at NASA Goddard Space Flight Center, didn't want the seeds to go to waste. After finding out about their existence in 1996, which was a whole 25 years after the mission, he made it his goal to track down the so-called moon trees and record the results in a way that NASA had failed to do. He has since created a registry that explains where all of them went, and while some have since died out due to poor soil conditions, he concluded that the moon trees had grown in exactly the same way as would normal trees. And while this may not seem like crazy news, the fact that we can bring seeds up to space and plant them again is huge, in that it suggests that we'd be able to grow plants on a hypothetical space colony on the moon, or maybe even Mars. Number 2. Growing two-headed worms. In ancient Greek mythology, Hercules had to deal with a multi-headed monster known as the Hydra. While Hercules did prevail in the end, it proved to be a difficult battle. After all, when he chopped off one head, two grew back in its place. In a weird intersection between the mythical realm and reality, a flatworm aboard the ISS did the exact same thing when it grew back two heads after losing one. You see, flatworms are regenerative creatures. In other words, when they lose a body part, another grows in its place. In order to see whether the vacuum of space would affect this regeneration, on January 10th of 2015, a rather strange mission was conducted. 15 flatworms were severed at the head and tail, housed in a tube filled with half air and half water, and then shot up to space to spend 5 weeks on the ISS. Since electromagnetic fields and other biophysical forces such as gravity are believed to have an effect on the regeneration, scientists were expecting to see some pretty wacky stuff. And wacky stuff they certainly got. You see, on Earth, flatworms can grow back practically anything. However, under normal circumstances, they will virtually never grow back their heads. However, one of the flatworms in the group not only grew back its head, but grew back two heads, making it a true genetic anomaly. Besides the decapitated flatworms, another group of flatworms that were not decapitated in any way were sent. Incredibly enough, these flatworms also came back entirely different. For example, a total of 11 proteins were secreted in the space flatworms that were not secreted by their earthly counterparts. Just as strangely, the flatworms were practically immobile and spent just 70% of their time in the dark as opposed to the 95% that would be expected from the normal flatworms. Therefore, this strange experiment is not only proof that space can have a massive impact on animal species, but also proof that their regenerative effects can be altered in a way that could be beneficial to us here on Earth. Number 1. Space mice. For some reason or another, mice have found their way into more than their fair share of scientific experiments, and space experiments are no exception. And while mice have been launched into space since the 1950s, it's in recent years that some of the most interesting mice experiments have happened. For example, in 2019, a group of genetically modified mice were launched up to the ISS. What made these so-called mighty mice different than their terrestrial cousins was that some were treated with an agent known as the ACVR2B receptor. This agent is important because it regulates myostatin and activin, which are the molecular signaling pathways that can influence and regulate bone density and skeletal muscle mass. Now, that leaves us with an obvious question. Why block something that should be supporting the mice's bone health? Well, you see, under normal circumstances, mice lose bone density and muscle mass while in space. However, without this receptor, some scientists hypothesized that there was a chance that this bone and muscle decay would not happen. The end results were incredible. The GMO mice not only largely maintained muscle mass and bone mass, but many even increased it. Meanwhile, the untreated mice experienced significant decreases. Now, if that wasn't cool enough, the mice that received the receptor treatment also showed enhanced muscle mass recovery when on Earth, suggesting that the lack of the receptor was buffing them up. And while it's unlikely that scientists will completely block this same receptor in humans for fear of the side effects, the knowledge that blocking it has such powerful effects will help influence the creation of drugs that make spaceflight easier on human bodies. Ultimately, space mice experiments didn't stop or end there. In 2019, a different experiment involving 20 female mice shot them up to the ISS to see if their behaviors would change or remain largely the same. While it did take them some time to adapt to microgravity, behavior such as self-grooming was maintained, and after some time, they used the lack of gravity to conduct normal mouse tasks such as running and eating. In fact, they even began to exhibit distinctive circling or race-tracking behavior that evolved into a coordinated group activity, which is believed to have been caused by some combination of the stereotyped motor behavior, the need for the rewarding effects of physical exercise, or the desire for vestibular sensation produced via self-motion. So, I think it's fair to say that mouse experiments in space can provide some pretty interesting outcomes. I'll see you guys next time. Thank you to our channel members.